Last one. So, or last one that I can think of for now. By the way, the end result of all this, there will be draw a graph. Good part is a graph's worth a lot of marks, and you know from graphs in the past that anything that's obvious, you can put them in, you'll get the marks, or 1 mark out of 3 or 2 marks out of 3. So in that previous bit of the video, I showed you that there's a, whatever I said, it was a local min at, I can't remember now, at 1, and a local max at 2.25 or something. So you can just, on your graph, you can go ahead, you can say, well, I had one at 1, I had something at 2.25, so somewhere here I got a max, and somewhere here I got a min, and it tells you a fair bit about the graph. The rest of it, you can just follow the gradient. So if they talked about the gradient here at 0 was, I don't know, let's say it was minus 3, and so it's coming down, and you can figure out what's going on with the graph by looking at the gradients and figure out what's going on. It doesn't mean you know exactly where these values are, but you can have a pretty good idea of where they are and draw the rest in. So hopefully you've seen that before and figured it out. But anyway, let's go back to this idea. This is really obvious, but I know most people will get it wrong. I'm always exasperated with it. So I could just ignore that for a moment and say, what does an integral do to a derivative? It makes it not a derivative. So this is weird. To me, it's really stretching the friendship, but it's common sense. What does an integral do to a double derivative? So what does an integral, let's do it as a single derivative, minus 3. So what does an integral do to a single derivative? It turns it back into the function. So we're anti-differentiating the function. So what would it do to a double derivative? It turns it into a first derivative. Oh my goodness, I wish it wasn't in there, but you know, people make this up. This could happen in the race this year and they've got no idea that he had these questions in. So that one's going to become that, but here's the scary part, or the part that people will make a mistake on. We're integrating. So if you were integrating, I don't know, let's go x squared minus 3 dx. So if you integrate that, you know it's going to be an x cubed on 3. So we're taking it back up, so the integrating increases the power unless it's an exponential or a sine or a cos. So what we're going to do is, we're anti-differentiating, goes back to that. So we're anti-differentiating, goes back to that. Well, what happened to the 3? Or the minus 3 in this case. It becomes a minus 3x. So watch out for that trap as well. So this one's going to become minus 3x. So there's one of the traps here. So if you anti-differentiate the second derivative, it becomes a first derivative, and the minus 3 becomes a 3x. And then, of course, if you're going to substitute values like 1 to 4, that's where this is going to come back in with the 1 to 4. So if you put that here, we know we're going to substitute the 4 and put it into this one. So we're going to get the derivative for 4 minus 3, 4 is a 12, minus brackets, Griff, brackets, mate, Zach, brackets. I don't think Zach has a problem with brackets. Put the brackets in, so, and then we're going to substitute 1. So it'll be the derivative for 1 minus 3, 1's a 3. And there's your answer to the question. Of course, they're going to say to you that f-4 is such and such. And you can look up what it is. So, I should do it. Here we go. Don't want it to become too long, guys. Anyway, you used to be prattling. f-4, say that's, I don't know, let's make it 8. And let's say that f-1 is, let's make it 2. So then we're going to get f-4 is 8 minus 12 minus brackets. Graph, put those brackets in, mate. f-1 is 2, take 3. You can see that's going to be a negative of a negative. Don't get sucked in. So that's a minus 4. Minus 1 is plus 1. Who was that? Last test. Oh, Zach. Zach had 1 minus 1. Watch out, Zach. That's 1 plus 1. I think it was you, Zach. Sorry, mate. 2. So what's the problem there? And you end up with minus 3. But if you do the stupid stuff that a lot of you did in the last test, when you didn't recognise it's a reverse of the chain rule, or you didn't realise it was a product rule, one more statement on that. So if you had, you know, a 2x sine 3x plus 1, and was it Daniel? Daniel, mate, it's got one function times by another function if you were differentiating it. So that's your u and that's your v. Watch out, mate. So if there's an x here and an x there, you can do that. reminders of things like split the fractions. I know some of you are really puzzled on split the fractions. There are some, there's times where you'll see a question, you've got no choice but to split the fractions, especially when it's an integral. So, if I gave you 3 root x plus, I don't know, let's make it x squared over x dx, there's no way you can do that without splitting the fractions. So you have to go that over that, and you have to go that over that and split it into the 2 fractions. Anyway, prattling too much. Thanks guys, bye for now.